Good morning or good afternoon, depending on what time frame you're watching this. My name is Professor Galvis, and this is a lecture on packing and processing. If you hear the audio, it means that this lecture has gone fully online. There will also be a PDF version of this on your Blackboard for you to print and follow and take notes if you would like, or you can take it anywhere with you and follow the PDF version, or you can probably just watch this on your phone, whatever you prefer. So, as we begin, goals and objectives of this course are to define and identify the following terms, analyze differences between different types of acrylics, procedural steps in packing, and procedural steps in identification of complete dentures, and evaluate some things, disadvantages, advantages of heat cure and cold cure acrylics, indications of heat and cold cure acrylic, and possible outcomes of packing and processing. So to begin, the stage that we are at in lab is that we have our flasks that have been boiled out and wax elimination procedures have been completed. So at this point, let's talk a little bit about tinfoil and tinfoil substitute. Plaster and stone absorbs fluid. It's a porous material. With that said, monomer, which is the liquid form or part of acrylic, we'll talk about the two parts of acrylic later on in the presentation, but the monomer penetrates the mold surface, and the acrylic can actually kind of fuse to the stone. So what you end up with after processing is the stone is stuck to your acrylic surfaces, which can be very difficult to remove, and you want to avoid that at all costs. So what do we use in order to prevent that from happening? In the past, we used tinfoil. If you reference figure 2, you'll see that it basically looks like aluminum foil you use in your kitchen. But this is a little thinner. This was used to apply over the stone surface, and then acrylic was applied on top during the press packing. Nowadays, more commonly used is tinfoil substitute, also known as a sodium alginate solution. And we're going to talk about the application of tinfoil substitute right now. So this all has to do with model preparation for packing. To use the tinfoil substitute, like we spoke about before, eliminate all wax residue from the mold and carefully apply the separating material to seal the surface completely. Tinfoil substitute flows more readily and penetrates the mold surface better. This separating medium reacts chemically with the surface stone, creating a microscopic layer sealing the surface of the cast. A visible buildup of separator is not necessary to be effective, and you're going to apply this in 2 coats. If you apply it too thick, it will almost create a gelatin consistency, and that can kind of play with what your denture is going to take the shape of, right, when you're pressing acrylic into the stone. So you don't want to lather this on too thick. So while the mold is still warm, you're going to apply a coat of separating material to the lower half of the flask. You're going to paint the separator after the steaming action of the mold has stopped. The steam escaping from the stone can cause the separator to kind of lift from the model. You don't want this to happen because you'll just have to apply it again. So you want to wait until the temperature kind of cools. You don't want to apply it while it's steaming hot. As you see in the video, this is the proper application. You're going to apply 1 coat, let it dry, use 2 coats every time. So once the first coat dries, you use the second one. We're going to talk about polyethylene sheets a little later, but basically what happens is the sheet is placed on top of the acrylic, and that sheet allows you to open the flask multiple times without distorting the acrylic that you've already packed. When using the sheet, there can be times that it will lift this tinfoil substitute layer off the model. If it does, you will just have to apply another coat. So once again, you can see here just painting the gypsum structures with tinfoil substitute. Very important note should be that we spoke about denture-based material being made out of acrylic just like teeth, right? Talked about porcelain teeth and plastic teeth in previous lectures and how plastic teeth bond to the denture base. Now, if you get tinfoil substitute on the ridge lap surfaces of the teeth that are connecting to the denture base, what do you think can occur? If it's a separating medium, that probably means that acrylic will never reach the tooth surface and bond. So a patient will go home with the denture, and maybe a week later, number 8 will pop out, and now the patient that paid for a brand new prosthetic is now missing a tooth because we didn't pay attention to our separating application. So how do we avoid that? If we get it on the teeth, you can easily just paint monomer on the teeth to remove that tinfoil substitute and inhibition layer that has been created. Now we're going to talk about the different types of acrylic that can be used. Mainly when it comes to compression pack, and what we're going to be using in lab is heat-cured dentured resin. So it's the principal kind of resin used for denture bases at the present time is polymethyl methacrylate. Polymethyl methacrylate is the chemical term. You also hear in dentistry the term PMMA. That is an acronym for polymethyl methacrylate. So it's usually supplied in monomer and polymer, which is liquid and powder. Easy way to remember that. Polymer is powder, P for powder. So they're mixed together, usually in accordance to manufacturer's instructions. And the result is like a dough-like mass that can be easily shaped to fit a mold space. So if we get into what that looks like, you'll see here that after the two halves of the mold are closed, before that, the acrylic is applied into the cavity, and then the halves are closed, and even after the monomer and polymer continues to change in its chemical reaction until completion. So what originally is the dough-like substance you see in this video will then become a solid plastic. So now let's talk about acrylic themselves. All right, so different chemical properties of acrylic. The chemical reaction that takes place when acrylic resin dough is converted into a solid is called polymerization. Okay, there are two classes of acrylics here that we're going to talk about. We have heat curing and chemically activated. The division is going to be based on how the monomer polymer dough is changed into that plastic state. All right, so basically how it's polymerized is the difference. So how does heat cure acrylic work? Traditionally used for complete dentures, even used on implant work, heat cure tends to be the final restoration. So with heat curing acrylic resins, polymerization takes place by a process of controlled heating. The monomer polymer contained in the mold is raised to a temperature specified by the manufacturer for a specific amount of time, and that's what it takes to create a hard, dense, processed acrylic. All right, the method of applying heat can be in the form of a water bath, more than likely, and that's what we're going to be doing in lab class. But there's other methods of fabricating heat-cured dentures. Nowadays with CAD/CAM technologies, you can print, mill, and also there's injection methods. Heat-cure acrylic does seem to be the acrylic of choice when it comes to final restoration, however. So then we have our chemically activated acrylics, right? They also go by the name of cold curing, self-curing, or auto-polymerizing resins. So polymerization takes place without the external application of heat. The monomer portion of the chemically activated resin contains an additional substance. Excuse me if I butcher this word, but it's dimethylperitoluidine. It causes the monomer and polymer to polymerize without the need for heat to be applied to acrylic resin. So what are the indications for this kind of material? You'll see here repairs. It's a fast way to repair a denture and not allow a patient to be without a denture for a long time. Tooth fractures, base fractures, even sometimes relines, which we'll get to later on in the semester. And you'll see on the figure on the left, we have a RPD, removable partial denture. Some smaller portions of acrylic are easier to do in cold cure or self-curing resins as well. Advantages to heat cure acrylic. Once again, heat cure resin is most commonly used for processing complete dentures in the dental laboratory. Some advantages are the greater color stability, greater strength, more resistance to staining, and less absorption of oral fluids. It is press packed, so the material is a little denser because it's underneath so much pressure, which then results in less porosity, less absorption of fluids, and then leads into the resistance of staining and good color stability. Now, heat cure is not the only type of acrylic that can be used to process full dentures. We're about to show you in a second a sleeve pour technique and how to process a complete denture with cold cure acrylic. Now usually this is used for immediate dentures, but nowadays cold cure acrylics are so advanced that they are used for final restorations. So auto-polymerizing advantages: less dimensional changes than heat curing resins, faster curing times definitely, usually about 20-30 minutes, and heating equipment is not required for polymerization. If we take a look at the short video, you'll see that the denture is in place in a pour flask that is reversible hydrocolloid that can be melted down using a double boiler, sometimes a microwave. The temperature has to be just right. If it's too hot, obviously it will melt the wax denture. So it gets poured over the denture and then cooled for about 45 minutes in a water bath. Once it has become solidified, the model with the wax denture can then be removed from the flask. After it's removed, you can see there's a very detailed amount of information there. You cannot put this in a boil-out unit because obviously it would melt again. So what we're going to do is create sprue channels, and that's the way for the acrylic to enter and exit the flask. You can peel the teeth off of the wax, you can boil out the model, insert the teeth once they're clean, insert the model, and then pour acrylic from one sprue channel and let it come out the other side. Once that happens, you are basically left with a fully processed cold cure denture. So what we're going to be doing is packing. So what's needed? So meticulous cleanliness is needed. Really be sure that everything is clean and you don't want to introduce any foreign materials into the dough. The equipment needed is a glass ceramic jar. You can see there that you don't really necessarily need dental materials and equipment in order to perform these tasks. Any ceramic or glass jar will do. I seem to have a strawberry shortcake teacup. But as long as it's made out of ceramic, it will work. Now, you need a mixing spatula and 2 graduated cylinders. I used the term ceramic or glass before, and you'll need at least one of these cylinders to be glass. We'll talk about why in a second. You'll need polyethylene sheets, which are used for packing, and you need your flasks that are cleaned and boiled out. Now, why do you need 1 cylinder for monomer, 1 cylinder for powder? Because the monomer will actually eat away at the plastic and melt it. So the monomer cylinder has to be made out of glass, and the one that you use for polymer can be used in plastic. So in the absence of instructions from the manufacturer, the average ratio is about 3:1 when it comes to monomer and polymer for acrylic, heat cure acrylic. So you'll see that it's 30 cc's of polymer and 10 cc's of monomer on average. So what does the process look like? Well, here we go. You'll pour your monomer into your ceramic or glass jar and add the powder to the liquid. It is always recommended to do that in all forms of dentistry because it reduces the amount of air entrapment. Although at times in real life you will see that many technicians find it easier to add liquid to powder. But for the Air Force, it is always liquid and then powder. So you want to stir, but do not whip the mixture. You don't want to mix this like stone. You just want to mix the polymer around and moisten it with your monomer. You don't want to trap air. It could make it difficult later in the fabrication steps. You'll see me tapping the cup here. Basically what this does is the monomer rises to the top, and this kind of frees the residual monomer and allows that acrylic to set a little more uniformly. So once you have the right consistency, you don't want it to be liquid, you kind of want that sheen on the top. You're going to place a lid or a cover over the cup. You do not want any contaminants getting inside, and you're going to allow the mixture to stand for an approximate length of time. You'll then take off the lid or cover and check the consistency of the acrylic. So what you're going to be looking for is you don't want it to be sticking to the jar. And we're going to see now, the biggest question is, when do you pack? What is a good time, right? Well, we have different stages of acrylic. In figure 1, you'll see that it's very stringy, right? I like to say that it goes through a liquid to stringy to doughy state. However, some mixtures and ratios never enter that liquid state. They're usually sometimes always clumpy. But definitely acrylics, when it comes to heat cure acrylic, goes through that stringy stage you see on figure 1 and then transitions into a dough stage like you see in figure 2. So when do you pack? When the mixture is no longer sticky and does not adhere to the walls of the mixing jar, it is in the dough stage and ready to pack, as you see in this video. If you pack too early, what can happen? If acrylic resin is packed at a sandy or stringy stage, the material does not have enough body to pack well, and it doesn't really fill the mold as well, right? It just kind of slumps. It's not firm enough to hold dimensions. And packing it too early in a stage will cause porosity in the denture. What happens if you pack too late? Usually this will happen when you're packing a lot of flasks and you get to the last two. If the acrylic is too hard, you run the risk of it being so stiff that you'll lose detail in the denture base, you'll have possible movement of teeth, and you won't be able to close the flask fully, which then affects your occlusal vertical dimension. So the first steps include something called trial packing. So what is that? You're basically rolling the dough and placing it into the cavity in 3mm thick slabs. Be sure that you're only taking the shape of the denture, meaning that the lower should not have acrylic in the tongue space. So since the lower is in the shape of a horseshoe, then the acrylic being applied into the cavity should be in that shape as well, as you see in this video. So the objective of packing procedure is to simultaneously have a densely filled mold and metal-to-metal contact between the halves of the flasks. Steps leading to this goal are called trial packs. Right? Most heat-curing denture-based resins require at least 3 of them. So the plastic sheet, the polyethylene sheet, is placed between the flask, as you see here, and the flask is put together with just hand pressure. And it's going to be applied to achieve the initial closure. The flask is centered in a bench press, which you see here is a manual press. So you're going to slowly close the bench press, and the excess resin is going to escape from between the flasks. Slowly closing it also creates less likelihood that the mold or denture teeth may be fractured or dislodged. The flask should be closed within 3mm of metal-to-metal contact. So continuing trial packing, remove the flask from the press and carefully separate it. You're going to remove the plastic sheet and trim the excess acrylic from the border of the mold like you see in the video and in the figure 1 and 2. You'll see that it has spread onto the tongue space and has seeped out all areas of the flask. It's important to remove this flask because it's a film and layer that will prevent the flask from fully closing and having metal-to-metal contact. Now remember, this is only the first step of trial packing. You are to repeat these procedures 3 times. So after opening it, you're going to place trim the acrylic, then place a fresh plastic sheet over the acrylic and put the 2 halves back together. When you apply pressure for the second time, the flask should be closer than 3mm apart. You'll reopen and perform the procedures 1 more time, getting closer and closer to full metal contact. It should be noted there are multiple ways to pack. In this video, it's using a manual press, but there are other ways of packing, including hydraulic and pneumatic. Now the difference between the two is that a hydraulic is manual, usually controlled with some kind of valve that needs to be turned manually. And pneumatic is with air, but just automatic with the use of just a button. So all the pounds per square inch are already calculated in a pneumatic system. But one thing is for sure, no matter hydraulic or pneumatic, you should not exceed 3,000 pounds per square inch during the packing procedures. How do I final pack? So the difference in final pack is basically there is no polyethylene sheet between the flasks. So final packing and closure requires the removal of the polyethylene sheet during the final closing, as you see in video 1. You're going to place the flask into the bench press and achieve metal-to-metal contact fully. Now, once you've done that, you can hold the flask inside of the press for a little bit if you prefer. But right after that has been completed, you're going to carry it into the compensating press, which you can see in video 2. It's also known as a carrier press. So using the handle and wrench like you see in the video 2, you're going to close the press until the springs are completely compressed, and you'll back off about a 1/4 turn. This is going to allow for the expansion of the carrier press during the curing procedure. Now we can talk about methods of polymerization. Most commonly when it comes to compression pack method, the long cure method is used. So you're going to place the carrier press containing the flask in a room temperature water bath, also known as a curing unit. Heat the water slowly to 160 degrees Fahrenheit and maintain it at the temperature for 8 hours. You never want to put the flask into a hot water bath. It needs to be room temperature and then slowly reached to its target temperature of 160. In the water bath in which it's processed, you will let it cool down to room temperature before touching it and proceeding to deflasking. Now, traditionally, in the past, this was the main way to fabricate complete dentures. Because it was so time-consuming, packing was done at the end of the day. That way, everything was cured through the night. When everybody came into work the next morning, all the dentures were ready to deflask and proceed to the next step. Now, there's injection methods that can cure a denture in under an hour, and also CAM manufacturing, additive through 3D printing and subtractive through milling, that can also produce a denture in a fraction of the time. When it comes to the old school way of curing it in a curing unit in a water bath, there is a short cure method. You can place the carrier in a press, as you see, and heat the water slowly once again to 160 degrees Fahrenheit. Maintain that temperature for an hour and a half. Once you've reached that target temperature for an hour and a half, you can then raise to 212 degrees Fahrenheit, which is basically boiling. And at the temperature for 30 minutes, it needs to be there to complete the polymerization process. After polymerization, you should let it cool on the bench for 30 minutes, and then you can run it under water for 20 minutes. Now, with that said, it might only be 2 hours of polymerization process, but it goes into the water, you have to wait for it to reach temperature, and then you have to wait for it to cool. So all in all, the process before you actually retrieve the denture in your hands could be about 4 hours, so still pretty lengthy. And things to know about polymerization. Heat curing resins must be heated to at least 158 degrees Fahrenheit before polymerization begins. If the monomer polymer dough is heated to curing temperature too quickly, polymerization takes place faster. The heat of the reaction can drive the internal flask temperature to 300 degrees Fahrenheit. Why is that a problem? Because monomer boils at 212 degrees. So bubbles are going to be formed during the process, and that creates porosity in your denture. Now lastly, this was something that wasn't placed into the curriculum until recently, and it is now state law in New York and New Jersey anyway. So in relation to dentistry, the subject of forensics is increasing in importance. Many shortcomings in personal identification have surfaced as a result of findings during mass casualty identifications. There are fewer problems when removable denture wearers have identification. So you'll see in Figure 2, the way it normally was done in the past was just with a name tag, social security number, easy way to identify. Now things have gotten a little more advanced where they even sell microchips or codes that can be scanned on a phone that are tied to an app. These are the more technological ways of identifications on removable prosthetics, but we'll speak about that a little later in your laboratory classes. So we have paper strip technique that the Air Force talks about and shrinking plastic technique. So main differences are the paper strip technique is used only during the packing procedures. So what would basically happen is that you'd pack your acrylic, and then after you separate it during the trial pack procedure, right before the final pack, you'd cut away some acrylic and then place this sticker facing up towards the intagular surface of the denture. Then placing clear acrylic over it, you'd pack, and when you relieve the denture, the surface of the code, barcode, or name or social security number would be facing you out on the intaglio surface, and it would be finished as normal. Now, more commonly, the shrinking plastic technique is done, which is post-processing. So you'll see a video of this in your laboratory section this week. So they used to call it shrinking plastic technique because after putting the piece of plastic in water, it would shrink. Nowadays, you can simply print this on a clear piece of plastic and it would suffice. So basically all you're going to do is an appropriate area of the denture base where it's not aesthetically driven. You will cut a shallow recess that is deep enough to fit the identification label, and then on top of it you would just place some clear acrylic, cold cure, self-curing, And then you would place the prosthesis in a pressure pot, about 115 degrees Fahrenheit, 20 pounds per square inch for about 30 minutes. And when it comes out, you would finish and polish it. And once again, you'll see more of that in your laboratory section instructional videos. So that's it. At the end of every session, you're expected to go through these readings. This presentation covered mainly compression pack method. We did speak a little bit about the sleeve pour technique, a little bit about injection. The Air Force Manual covers these in more detail, so please perform these readings and familiarize yourself with those different procedures and materials. Once you perform these readings, the coursework would be complete for the week, and you can get ready for your midterm. So I appreciate your time. Hope you enjoyed the lecture, and I will be talking to you all very soon. I'm available. Email me, contact me on Blackboard, whatever you guys may need. Have a great day, guys.